Hey, how's it going, everyone? My name is Jaime Piña, and
And this is Waldemar Quevedo, or you can call me Wally. And we're part of the NATS team.
yeah, at Synadia. And today we're gonna give you guys an intro on NATS.
So yeah, we're
Mhm.
have a few demos prepared, and we'll give you a quick overview into the NATS project in case you're new into nats.io. You can find us more info about the project.
And
So
then down below, you guys can see there's a URL that's gonna be our demo that we're gonna show you guys later on, so you guys can actually interact with that live.
okay, so it says start sharing my screen,
Yeah, take it away, Wally.
and uh, not yet, I think. So can you see it now?
Yep,
Oh, okay, cool.
see the slides. Great.
Okay, so this is a quick intro into NATS. Again, it's Waldemar Quevedo and Jaime. We're NATS maintainers. Been using NATS based systems um, since I think on 2012.
Mhm.
You haven't heard about NATS. NATS is a high performance cloud native messaging system that keeps one of the main goals is to make building distributed systems more in a more simple way. It started with Cloud Foundry at the very beginning. It was written in Ruby, but since from the beginning, some of the thing that distinguishes NATS it is its simplicity and that always tries to be available. And also since it got written into Go, um, the performance is also there was a very big performance boost from NATS. Thanks to the simple protocol, you have many client implementations, and also there are some new projects that also enhance some of the um, feature set from the project to be able to have not only ephemeral messaging but also have persistent streams. The first iteration of that was NATS streaming, and also one in the incoming in the pipeline is Jetstream, which is another take on the persistent streams for NATS.
Mhm.
And since last week, NATS is actually a 10-year-old project. It's one of the oldest projects, part of the CNCF. Um, Again, it started in Ruby, but the protocol itself has not changed a lot since then,
Mhm.
which is, I think,
Pretty
speaks a lot of
stable.
like, yeah, it's very stable protocol all the way since its origins. I think the only main change into the protocol is another thing that is coming into the NATS 2.2 release, which is the next release from NATS, is the support for headers. So there's a couple of two new protocol commands that got added.
Mhm.
There would be hpop and the h messages, which is messages with headers. But other than that, it's a very backwards compatible protocol all the way from the first version of the server. And we say that it is we tend to say that NATS is very lightweight because it has no other external dependencies. So many new adopters from NATS actually really like that fact from NATS that there is no this and other external service that they need to be able to have or persistence for the streams or to be able to load balance the request to multiple clients. So if you need simple load balancing for any number of APIs within your microservice, you just only need a single URL, connect to NATS into your Kubernetes cluster, or we'll also talk about how you can expand these clusters to be like super clusters, clusters of clusters, um, which is pretty cool that you can do that since the NATS v2.
Mhm.
So it is a lightweight, no dependencies, very small Docker image, has a official Docker image, so you can only do Docker run NATS. Takes very little to configure it. And again, it is a very simple, straightforward API. So something that new terminology that I started using with the NATS v2 um, release is talk more about NATS in terms of streams and services. So we say that NATS is a stream, is essentially a sequence of data that you can also make it broadcast to a number of consumers. And so NATS is a publish and subscribe system. Whenever you have a consumer that you can ping many to consume from a stream, we are talking about those sequence of events, but you can also do a request response with NATS. So you can also do services similar to like doing like a REST-based design or gRPC endpoints for microservice communication. You can do the same with NATS. There's a request API that is also, you can use the QSubscribe API to make it load balanced.
Mm-hmm.
So
and some of our demos will show you how this looks in NATS. So
yeah, and the basic building block from NATS is the subjects. So you can have a very simple subject, something like a foo or a weather, where you can get the latest stream of weather information. You can use dots to separate and make it use the wildcards to match into different number of the subjects in the tree. So you have a couple of wildcards that you can use. The asterisk, which matches only at that certain level of the subject. You also have the greater than or full wildcard that matches everything under that hierarchy of the subject. So you using those subjects, or that might be to like channels or streams or services, you use the APIs from NATS, which is that request reply in case you're talking about services, publish and subscribe if you want to use streams. And in case you want to enhance with load balancing, you use QSubscribers, or which can work with both streams or services. So I can give you a quick demo of how this look like first. Need to, I think I'm showing it on the slides.
yeah.
And actually, I'll share some of the accounts isolation actually at the same time. So you can do with NATS, each one of those subjects can become part of the, am I sharing the screen? No. Okay. Share once again, creation window, this one.
There we go.
Okay, yeah. So streams, Synapse V2 accounts are, or those subjects can be isolated into accounts, or you can think of them as namespaces for your subjects. So you can have multiple accounts, which is a collection of users that export or import services from another account. In this case, we have a stream, which is the Acme stream that is going to be, means that has as a client that is periodically publishing data, in this case on the acme.hello subject. And then you can have a user from the CNCF account that is importing and mounting into its own account to be able to receive any event that is being published by the Acme account. So this is an example of a stream. And you can also have services. So these services can also be isolated with accounts. I mean, that here in this example, you have an Acme account that is exposed via the Hello service subject. And then from the CNCF, this other account, you can use within your own subject namespace, how you can define how you want to use this other API from this other subject. So this is what I want to show how it looks like. And let's see. So I guess I'll share the whole screen now. Okay, so can you see whole screen, Jaime?
Yep, I can.
Okay.
Can you make the text a little bigger?
Yeah. I'm going to start with the streams example.
Cool.
Making a connection to NATS. So I have a couple of users on their different accounts. You have the user Bob at the lower bottom of the screen. And Alice, who is connecting and emitting events. So if you do streams, need to start the server.
Yeah, so this is one cool part about NATS is starting the servers like just a command. It's really easy to start. Just like yeah, not a big deal to start the server at all.
So yeah, this is there's no other config required by the server, so it means that it is binding to localhost. Sorry about the train, that's me.
Okay.
You have something like Nginx that can be useful for testing the configuration, and -t to validate if the format is okay. We're using .conf. It's a special configuration format for NATS, but it is actually JSON compatible. So you can use JSON to be able to define all of this in case you want to generate this on your own. But it is has a lot of syntax sugar, the configuration format.
Yeah, it's very flexible.
So, -d-v, you can use it to enable a login and verbose for the server. And it is going to complain because we're using plain text passwords. That's one of the changes with NATS v2. And it will suggest to use either bcrypt for the password. So you can define in your password this with bcrypt, or you can use also nkeys. And nkeys is one of the things that is kind of like a PKI scheme where you can have each one of the users has a public and a private key. And then the server will make a challenge to authenticate that server. And also, this is all the centralized configuration style of using NATS. There's another mode where you can switch everything into use JWTs so that the configuration from the server is all decentralized. So it's again, hello world. Let's start the stream. And the consumer streams. So now I'm receiving messages from this other account. So you can see that we're publishing into acme.hello, but when we receive the messages, they are being received under the imports.acme hello subject, and we are matching using the greater than the full wildcard.
Yeah.
If I make a mistake with the configuration, I'll get a authorization violation error. We can, so these are our streams. Let's do the same with services.
And we'll also show the JWT authentication style that Wally mentioned earlier, so you guys can check that out. There's also like token authentication, right, Wally? So there's different ways to authenticate.
Yeah. There's the number of ways you can authenticate with NATS has evolved quite a bit. You can also use, for example, the relative distinguished name from the TLS certificate to be able to match that into the identity from the user. So that's one of the features that are kind of popular with NATS, where you can map it instead of define, for example, Alice here, you can define an SVIT, for example, for Spiffy, something like Spiffy. So Spiffy and then match that under the one that the TLS, what is called the SBIT from SPIFFE, from some theme, for example, user. And so you can use N keys and basic tokens, bcrypt. You can, if you embed the NATS server, you can also have your own custom authentication if you implement the auth interface. So embedding the NATS server is actually pretty common. There are some projects like Micro that is embeds the NATS server for some of the pops up. So this is the service example, and I should be. I need to restart the server here.
Yeah, that's kind of interesting too, actually, huh? So people can use the NATS server just by importing like the Go code, and then do whatever you want.
Yeah, and we see that when the service is going from one account to the other, where's the requester? So here we have a requester is periodically making a request every second under the CNCF hello subject. And then we have a queue subscriber that is part of a worker group that can take one of those messages and respond to any client that is waiting for a response. And something interesting here is that, so NATS is, again, basic, it is pure publish subscribe. Whenever you are sending a message across accounts, there is going to be a remapping of the accounts. So in this case, you can see that the way that a request in NATS works is that it's just an inbox, a unique inbox for each one of the clients. When it traverses into another account, it becomes a special subject called _R that is hidden by the consumer of that message, or the subscriber that is receiving the requests. Mm-hmm. So all of this happens transparently for the clients.
And the inbox and the R, they're just subjects, right?
Yes, yeah.
So cool, nothing fancy there.
Yep. So this happens with them. So this is basic building blocks from using NATS, just doing the publish subscribe. Mm-hmm. And with the NATS v2 series, the number of topologies that you can use with NATS also increase significantly. So you can do not only clusters, but which in the same data center, but you can also have the cluster for clusters. And with the leaf nodes features, you can also have edge devices that are connected. So a couple of weeks ago, I gave a demo of using the leaf nodes and one of a very simple MicroPython client that was running on a microcontroller and connected. So can you see the slides once again?
Now I can, yes.
No, you can?
No, not anymore.
Okay, sorry about that.
And
so this.
Now
okay.
Okay.
Yeah. So unlike NATS v1, where the classic usage was to have a NATS within a single data center and have the classic way was like communicate within for microservices in a very simple way. With NATS v2, you can also have make a composition of clusters. So you can have a multi-region and then have a gateway connection. That's how we call them, between many of these clusters. And then the server will be aware of how to route properly based on the interest, the messages. So you can publish a message from, let's say, in this case, from a cluster in San Diego, and have someone interested into the subject foo from a cluster in Berlin, and it's going to be forwarding the message. And also you are using services across these different clusters. It is going to be able to determine whether, based on the RTT, which is the appropriate load balancer node that is going to that should handle that message. And in case there is no local queue subscribers, then it's going to be forwarded into a different cluster that is part of the same supercluster.
So this way, like the load balancing always gives you like the lowest latency, right?
Yes, yeah.
Okay.
And also, you can extend these superclusters by using the leaf node connections. And leaf node connections are kind of like a proxy, but it's it is itself more NATS. So you can have, in this case, an edge device that it is not being able to do some of the more expensive authentication operations. So you can connect into your own attached or kind of like a sidecar leaf node. And then this other leaf node will have the secure TLS connection to the supercluster. And you can also take advantage of this pattern to create like more very complex network topologies. For example, one of the very cool use cases from this was a very recent project from IBM, and they were using this mapping the leaf node connections are kind of like satellite nodes, and then the ground cluster was a super cluster that to which simulated satellites could connect into this ground cluster, and through the ground cluster connections, multiple leaf nodes can actually talk to each other. So you can have multiple satellites on the edge, be able to satellite A communicate with satellite Z from all through the same supercluster. And they themselves are also clusters. So this has evolved into what we call the NATS adaptive edge architecture. So which is a pattern that we have seen get picked up by many of the users in the community, where you have a centralized supercluster that could be like some in some cloud, for example, like AWS, Azure, and then you can connect your edge devices or your local superclusters on the edge, have a single leaf node connection to this other cluster to consume some of the services that are only on the cloud, but still be able to use NATS to communicate among them locally within the same DC. So NAT gateways, leaf nodes, superclusters, those are very cool features from NATS. And something that is also happening with the NATS v2, it's that is coming it's coming soon, is that we also support support more protocols, and one of them is WebSockets. It was one of the highly requested features. So Jaime can give a quick intro of how you can enable the WebSockets for your NAT server.
Yeah. One thing also I wanted to mention before I get into it. So Wally keeps saying V2, and normally V2 sounds scary because it might be breaking changes, but actually NATS is, like Wally mentioned earlier, pretty super compatible, backwards compatible. So you could actually, if you're on V1, you could actually use V2 as a drop-in replacement. And we've seen some users just switch to V2 and automatically like get performance boosts. So
yeah, definitely there is a significant performance boost with when you're starting to use NATS v2, and compared with NATS v1, in case you were worried about the explosion of subjects and the cardinality, especially millions of subscriptions, that is solved seamlessly with NATS v2.
Yeah, so that's pretty awesome. So let me share my screen. Just gonna get something ready. So I'll start sharing my screen. And can you see my screen, Wally? Oh yeah, I think so. Hello, this one. Okay. So I'm kind of gonna repeat a little bit of Wally's demo, but in a different environment. So we're gonna do it in a web browser. So that's one of the cool things about NATS, is that you can use it in all sorts of different environments. So ideally, it might be really cool to like just get everything on NATS, and then you only have to worry about like one transport system, and not have to worry about like, oh, we're using WebSockets over here, so that's this format, and gRPC over here, that's that format, and REST over here. So it'd be pretty cool if you could like unify everything. So here, again, we're going with streams and services. So as Wally showed, a stream, you just publish data. And let's go over here. Oh, yeah. Oop. This was... these are some... so here I'm just starting a NATS subscriber. I'm passing in some creds, and I have a server running on localhost 4222. As Wally showed earlier, it's really easy to just start the server. I'm currently using a server that I got from Master, and that's because that's where the WebSocket support is. In case you're going to try this at home, grab a later version. Down here, you can ignore this. This is Python server for the index HTML that I'm gonna where I'm running all this JavaScript. But yeah, it's really easy. Like Wally said, there's no like external maintainer like app or anything that you need to run NATS. You just start it and that's it. For WebSocket, this is the configuration you're gonna need. So I'm listening on port 9222, and I set up some TLS. You probably would want to do that if you're running this in production. And that's basically it. I have debug and trace true, but that's not necessary. Yeah, it's pretty easy to enable WebSocket.
Yeah, never enable debug and trace in production.
Oh, okay, yeah.
The performance drops at least half when you have this logging, so it becomes quite verbose.
Okay, yeah. Useful for debugging, but not useful for production. Noted. So those errors are from that I killed it earlier. Okay. There's one more thing that I wanted to get. Actually, it was over here. These, by the way, these NATS sub and NATS reply, they are example programs that we have. So you can just grab them from here. So nats.go, this is the client library for NATS, and this is where I'm grabbing all those programs. They're really simple. They're just like CLI tools that interface with NATS. So I'm gonna grab this one. So this is just a responder. It's gonna respond to any requests on service.foo. It's just gonna reply yes. So this is the subscriber. This is just going to publish anything that comes on events.foo. And this is actually interesting. So it disconnected, but it reconnected automatically. So all that is taken care of in the client libraries. So now we can go back here. So here's just a little log message that I connected to NATS. And let's take a look at the JavaScript now. So this is just, I'm not using React. This is really just index HTML. Obviously, this works with React and stuff like that, and we'll show you that in a bit with our chat app. But I just wanted to show like the bare bones, like stripped down usage of this. So first, we're importing, it's using ES6 modules. And so we're importing that first. We have this thing called a string codec. So NATS, all it cares about is moving bytes. It doesn't care about whether it's protobuf or JSON or anything like that. And this is true with all the client libraries. It just cares about moving bytes. And so you can put whatever format you want on top of that. So string codec here just translates between a string and a uint array. So that's why we have that. We also have, Wally mentioned authentication with JWTs. So this is our way of distributing authentication among NATS users in a cluster. And so this is my credentials file. I actually didn't configure credentials in the server. And that's because I swapped this out last minute so that you guys could see how I ran the server. But there's a little bit more configuration necessary if you wanted to use JWTs, which is all in our doc sites. So how we actually connect is we just call connect. We pass in an address of a NATS server, And we're using just regular, normal, typical WebSocket protocol. And the S is because we're using TLS. And this is how we would authenticate with credentials. So that log message that I got over here, logging it here, and here's what the JS API looks like. So first we take in some text, and then we publish it, and that's it. It's pretty simple. Here's the event. Here's the subject we're publishing it to. And so this is a stream. So let's go look at that real quick. So like I said, the data can be whatever. It can be foo. You can, if you want to use JSON, go ahead. All you need to do is on the other side of the app, like, unmarshal it correctly or whatever. So our subscriber picked it up. Here's the foo. Here's the stream. And the interesting part here is that the subscriber is on a different protocol. So NATS : / is actually just using a TCP connection, whereas like a plain raw TCP connection, whereas over here we're using WebSockets over TCP, but a different protocol. So this way you can have your servers in the cloud use TCP, but maybe you have web apps or like mobile app or something, and that can use WebSockets, and you don't have to like figure out some translation layer or something. You could just use NATS directly. So that's Oh, go ahead.
And in the roadmap, there's also support for MQTT incoming. There's an MQTT branch in the server where you can see how is that features ongoing. But yeah, also part of the roadmap.
Yeah. So that's awesome. You don't have to build your own translation layer or whatever. So a service, right, is you send a request, you get a response. So is it sunny outside? Obviously, it could be whatever, but yes, okay. It actually is sunny outside right now, so that's good. And on the client side, here's where we received the request. So server sub foo, and it replied yes to us. So here's what that looks like in JavaScript. So we send a request, we get a promise back, and then we just check or do update the UI in the body here. And here's where we can check some errors. There's also actually an error handler that will get called asynchronously if there's like any disconnect events from the server, which actually we'll see in the chat app. When Wally revokes a user, the NATS server will send back an event to the JavaScript client, and then the JavaScript client will be able to update the UI. But yeah, so this is super simple. So you just connect, you pass in the server. If you have authentication, this is how you would authenticate with the creds. And then this is how you publish. And this is how you send a request. And here's where you get the response. And you do what you need to do. And that's it. It's pretty simple. Configuration-wise, it was just WebSocket, this WebSocket stanza, the port that you're listening on, TLS if you want it. Debug and trace, don't use production. Slows things down. Oop.
So for KubeCon, we prepared this chat demo that we're kind of like putting everything together, all the NATS features, adding some of the decentralized authentication, WebSockets. So I'm going to show that setup in a bit.
Yeah.
Share whole window. You can find that repo on the NATS.io KubeCon 2020. The session itself is called From Zero to Hero. You can find a link to the KubeCon session here. But yeah, basically the output from that session is already here. You follow this, you can set up a decentralized chat in this case, we're using a DigitalOcean for the cluster. And yeah, in the talk, we go through some of the steps and explain a bit of what is involved in each one of those And so the way this is working is that we use NSC is another tool that you can use with NATS, and that it is can be used to be able to manage these JWTs. So in this case, we have set up a number of accounts. It will make. I have to show this first. So this is how the NAT server will look like. So we have a couple of we have a terminal-based UI. In this case, we have that where you can connect from your own terminal, also using the front end that Jaime did. There is the
2 clients.
Websocket.
Yeah.
Yep.
Exactly.
Yeah. Both clients, all this NATS-based pops up. One is terminal friendly. The other one's based for the browser. And we have created 2 accounts for this. One account is solely for the purpose of managing users and be able to get into the system, which kind of like the admin credential, the admin account. And the admin account is responsible for managing those users that become part of the service. But the users themselves are part of a different account. So that way we have separated these subject namespaces so that you cannot have like any as you have as less as possible cross-talking and data sharing between those 2 simple different accounts. So if you haven't checked the service already, let's chat. So you can log into the server, and I'm gonna log me in Wally 22. So I got an error because the user was already taken. But essentially, what is happening here is that I'm registering a user by being dynamically provisioned new credentials. So you can have in this Kubernetes cluster, I have a credentials provisioner that is able to issue new credentials based on the. Wow, this is interesting. Okay, so I can see anyone that has attempted to register into the service. I see Jaime, Wally QS, someone D has just registered.
Yeah.
And all of these are sending some heartbeats, depending on the client that they're using. So hello, everyone. Talking through NATS. But so this is the user UI, and in my case, I have the credentials for admin purposes as well. So I have the.
Yeah, you want to be able to provision users, but you also want to be able to revoke them. And yeah, obviously you can do both.
So let's see. Here I have the chat access credentials. And what is the endpoint, once again, Jaime, for the admin?
/admin.
/admin. So no one can see this. Okay, HTTPS.
Well, people can see it, but they can't log in.
Yeah. So you need to, in this case, you have to drag and drop or the credentials to be able to find these other users. So now I have drag and drop my credentials. I see who is in the system. Let's disconnect someone. I'll revoke this. So I can just revoke everyone, actually. Let's revoke.
So we're able to, with NATS, you're able to like kind of customize different users' permission levels.
So in this,
in addition to isolating them, yeah.
So as soon as I hit the revoke button here, I'll see Wally QS 22, I think. Yeah. Goodbye.
Boom.
So the account has revoked.
Yeah.
And what is happening here is that as part of the provisioner, we're using some of the account management APIs from NATS. So these provisioner, and you can know more details of how this is working in the KubeCon session, but it's essentially a service that takes a subject name and can issue new credentials, a new JWT that will allow you to log into NATS as part of a certain account, and will also make a request to the NATS servers to revoke a user. So in this case, we are revoking the public key. We're only aware of the public key that identifies you within the system, signing the JWT, and then sending that back once again to the NAT server and making a request to the NAT servers. This is a special subject for NATs to be able to manage accounts. Here, this would be the public account end key from the server, from that account. So now you know that certain user is no longer should be revoked access.
So the JWT authentication, I guess, uses a JWT and also uses N keys, right? Which is like
Yes.
a key pair for the user.
Yes. So I will not show the admin credentials, but I can show, for example, if I make a credentials requests, this is going to be find name. So you would see that nats.chat is the endpoint to talk to the WebSockets, but actually the NAT servers are behind the sfo.nats.chat. So it's just a single NAT server, all deployed with Helm, the Helm charts. You can see using external DNS for NAT server. In this case, had another SFO NAT server. Okay, so here have the Helm chart that is setting up this cluster. And you can now connect into the port 422 to talk to NATS. So you can list accounts. Let's generate credentials.
Also,
That would be
you can one useful tip for debugging NAT servers is you can use Telnet. So if you're like on a restricted environment, you don't have to download the NATS tools. You can just straight up use Telnet.
chat. What is the? I think the subject is chat access, I believe. Well, it's in the README.
Yeah.
A request for new credentials. This is already taken, so another one. So yeah, this is I get a JWT and the private key just for this user. So now I can. If you want to look how this look, just go to jwt.io. You can see that as a user, with using this user key, you can publish into online posts DMs only, and you're only able to receive messages under your own public key and able to reply into the inbox. So that way you can, that is how the DMs are working, by having the provisioning only and making sure that this user is able to talk to the, subscribe to the DMs for this user.
Mm-hmm.
Okay. And so already did revoke. Want to check if there's any questions in the chat. Not sure. You can see, where's the, yeah. So I think that's it for the couple of demos that we had for this session. And definitely check out the KubeCon session, some kind of like a deep dive in some of the internals from how this works.
Mm-hmm.
And stay tuned for the 2.2 release for NATS, which is coming soon.
Mm-hmm. We could also show some of the JavaScript for the NATS chat on the NATS chat side if we wanted to.
Oh, yeah.
Okay. Yeah, just do that. Although it is somewhat similar. So on the NATS chat side, this is now like a React app. So this is one way you could maybe lay out your React app if you're going to do that. So there's 3 pages. There's the admin, there's a welcome, and then the / is just the main chat app, I guess. So for the welcome page, I think Wally touched on a little bit that how we're doing the authentication is that there's like a default set of creds that have like basically no permissions. And this is in the README and the KubeCon chat. We talk about this a little more. So it's just like a default set of creds that can only request creds. And so we again connect to the NATS server with these restricted sets of credentials. We request upgraded credentials based on username we give, and the API will either grant us the new credentials like Wally showed, or it'll give us an error if they can't provision those credentials. So here's where we do that request. Here's where we we retrieve or pull out the credentials from the message, from the reply message that we get from the provisioner. And we're doing something interesting here where we're closing the original NATS, not less restricted, actually, more restricted. We're closing the original more restricted NATS connection because now we have upgraded credentials. If we get any errors or anything, here's where I'm checking them. So now that we have the full real credentials, we're doing another reconnect. So we like swapped out the connection with the upgraded credentials. And now that we have, and then in this next block, we successfully connected with the upgraded credentials. And so if we get here, we know we're good. The provisioner gave us new credentials, they work, and we now have like upgraded our permissions. So now we can go to the chat app itself. And so for the chat app, just when the page loads, all we do is connect with our new credentials. And we confirmed previously on the welcome page that this works. So this should work. And if it doesn't, then we'll go to like an error. But so right here, we're assuming that now we have a working NATS connection. And we're going to set up some subscriptions, which would be listening for streams again. That's like our main theme, I guess, streams and services. So we're tapping into some streams here. Here's where we get posts for the KubeCon channel, for the NATS channel, for the general channel. And Wally mentioned something about heartbeats. This is how we know who's online. So we're also subscribing to just user heartbeats. And we're also listening to direct messages, DMs to me. So it's a special subject where I'm using the public key. So that's how people know to send messages to me. And then here's where I broadcast my own heartbeats. So it's just to publish. And then I'm just setting this on a timer. And here's an interesting thing. When Wally hit that revoke button, I had mentioned earlier that the NAT server will send a special event. And so here's where that happens. So if this is like on closed, and so if we get an on closed event from the server, here's where we we notice that we've been revoked, and here's where we just update the UI for that. And yeah, that's actually kind of, that's the main chat part. For the admin, it's pretty similar. You might be noticing a pattern here with the JS stuff. Yeah, it's pretty straightforward. So here's where we connect with the credentials that were dropped in, and same thing, tapping into those streams, requesting some stuff on some services, and just saving that state in our app. So it's pretty straightforward. And it's pretty cool that you can use NATS on the web browser. You can also use it in the backend. You could use it pretty much everywhere with that MQTT support that's coming in soon. You can really kind of like round up all your services and just connect through NATS with them. So yeah, that's pretty cool. And yeah, let's see. And I think that's it.
Yeah, so we'll have this make some more touches to this NATS chat service, but we have it live during KubeCon. So looking forward to the session, and also let us know if you have any questions about using NATS, or and also always want to hear about NATS users or new ways of using NATS. So
yeah, we have a Slack channel as well. So if you guys want to join us on that Slack channel.
Yeah, it's not Slack.
Yeah, I don't remember what the URL. Oh, NATS.io Slack. Here.
Yeah, I can share that.
Or yeah.
Okay. Slack. So you should see. Cool. Yeah. Well, thank you, and I think see you in KubeCon.
Yeah, see you guys in KubeCon. Looking forward to some more questions over there, and let us know any thoughts or anything on IOSlack.com. That's IOSlack.com.